I will share my screen. Just confirm once you can see my screen.
Yes, Jackie, we can.
Yeah, it is visible.
Okay. So guys, welcome to 35th Surat MuleSoft Meetup. And topic for today's meetup is setting up MuleSoft Runtime and Anypoint clustering on Docker engine basically. So we will going to see how to set up a Mule runtime on Docker engine, and then how we can enable a clustering between a multiple instance of your Mule runtime on the Docker basically. Okay. So that is the topic. So I will recommend everyone to stay till end to see the demonstration. So demo is like more important, where like we will show the demo from scratch basically. Let me start with safe harbor statement. So both the speaker and host are organizing this meetup in individual capacity only. We are not representing our companies here. The presentation is strictly for the education or learning purpose only. Organization presenter do not hold any responsibility that same solution work for your business requirement. The presentation is not meant for any promotional activities. Some housekeeping activities. So the recording of the meetup will be uploaded to the event page within 24 hours. So later you can reference it if you want, if you need to clarify more thing. Question can be asked at any time. You can use the chat window, you can open your mic, and you can definitely fire any question at any time. Finally, like it's very important for us to get the feedback from you on the session and where we can do the improvement and what do you like about the session. Organizer, myself Jitendra Bapna, and like I'm working as a senior solution architect at EPM system, and I am the MuleSoft ambassador and leading various meetup group basically. Yeah, Nitish, you want to go next for your introduction?
Sure, Jackie. Thank you. Hi, everyone. Welcome to 35th Surat MuleSoft Meetup. I'm working for Accenture. I'm all MuleSoft certified developer architect. I'm also MuleSoft mentor, co-leading this group with Jackie. Welcome, everyone.
Thanks, Nitish, for the introduction part. I will just skip the Siddhima introduction for now. When she will definitely introduce herself. So once she will take over the session. So let me just briefly talk about the agenda. So we will discuss about Docker and containerization. What is Dockerfile? Then we will discuss about what are the seven steps to set up Mule runtime on the Docker. Then what is the next step basically beyond the Docker. Then we will see what is clustering, and then we will see how Docker, Mule runtime, and clustering work together. Then there will be Q&A session. Then finally there will be trivia queues. So I will hand over this session to Siddhima. So, Siddhima, can you take the session from here? You can share your screen. I will just unshare my screen.
Yeah, I'm going to share my entire screen. So, my quick introduction. So, I'm Siddhama Tigiri, and I have over 14 years of IT experience, both in Java, integration technologies, IBM Stack, and in Mule. I've been working for almost more than 4 years now, almost close to 5 years. And currently, I'm working as an integration architect with Devoteam here in Amsterdam. For the rest of the description, I would not want to bore you more with that. Maybe if you're really interested, you can just go visit my LinkedIn profile. So I would say let's get started. So as Jackie mentioned the agenda for today's call, um, we have these topics that we want to cover. We want to understand what is containerization, right? What is a Docker? What is a Docker file? How, and basically we're trying to make this very simple without getting into too much of details. There are a lot of different ways of how this can be done, but we would want to just break it up into simple 7 steps of how we can host the Mule runtime on the Docker. Yeah, so we just calling it as triple S. So you'd really, I'm sure you'd really appreciate the way it would be set up when you go through the end of this DIY session. Once we're done with the Docker setup and the Mule hosted on it, we'd also want to just summarize and let you know beyond Docker, what do we see, right? And then since we're also clustering these Mule servers that are hosted on Docker, if you'd want to touch upon the topic of clustering, uh, then yeah, so basically understanding how we are doing this clustering on these servers. So let me get started. So let's understand what is containerization, right? So I'm sure you know what is a virtual machine. So now we're talking about containers. So what exactly the word container itself describes itself, that it is self-sustaining. It has everything for itself to function independently. So what a container is, it's a standard unit of software that packages your code, all its dependencies, so that the application can run quickly and reliably from any computing environment, right? And you can port it, right? It gives you portability. And containers take up very less space than a VM, and hence can handle more applications, right? So you're getting more in less. So if I want to compare a virtual machine with a container, both of them would have physical servers, right? At the bottom, that is the infrastructure. Now for a VM, it would require a hypervisor, right? Based on which your entire stack of guest OS and you would need a VM, which would also require the guest OS where the applications will be hosted, right? So that's how the virtual machine would look like. Now, if you look at the container, yes, you have the infrastructure. On top of that, you have an operating system, a host operating system. And on top of that, you just have a Docker engine. And what this engine actually does is it hosts these containers. And each of this application is abstracted within this container. And it gives you, in fact, it gives you more space to have additional applications hosted and much more disk space. So it also depends how you're hosting it, but then basically this is the differentiation which you can actually look at the operating system level. Now, if we can move to the understand how Docker comes into picture. Now, Docker is a platform as a service product that uses OS level virtualization to deliver software in packages, right? Called as containers. Do not be overwhelmed with all these pointers if you're hearing it for the first time. I will walk you through the architecture diagram and you'll have much more visibility of what I'm saying when I say containers, when I say images, so you have a better view. So this is just more of a formalized understanding of what these terminologies are. So let's look at the first definition. What is a Docker? So Docker is a set of platform as a service products that uses OS level virtualization to deliver software in packages called containers, right? Software in packages, as in here you have Mule Runtime itself that comes in a package and it's containerized, and within that you can host your application, right? So that's your container. Now, containers are isolated from one another and bundle their own software, libraries, and configuration files, and they can communicate with each other through a well-defined channel, right? Now you might also hear of images. Now, what is an image? Image is basically a template, okay? It's just a template of instructions. It's a ready to run software package containing everything that it needs to run the application, right? So it's basically a template. So you'll see, how we create a Docker file and then, create the image. And from one image, right? From one image, you can spin up multiple containers. So just keep that in mind. With one image, you can spin up multiple containers, right? So I'll go to the next one. So we want to understand what is a Docker architecture, what are the different components of a Docker. So here, so basically Docker follows this client server architecture. So the Docker client talks to the Docker daemon, right? This client talks to the Docker daemon, and this daemon does the heavy lifting of building, running, and distributing your Docker containers. The Docker client daemon communicates using REST API, using Unix sockets or a network interface. Yeah. And another Docker client is the Docker Composer. You might not want to know it right now, but internally, if you're hosting it on your um, If you're hosting it on a Mac, it comes the desktop version installable. It comes packaged with the Docker Compose. So you might want to say, oh, Docker Composer was mentioned, and we're trying to search it. You're not able to find it. It comes packaged with it. But if you're doing it for Windows, you'll have to separately install that, right? So that's this is the architecture. Basically, if you look at this, the client will issue these commands for Docker build, okay, and then internally the Docker daemon would take those instructions. First it would create, first time the image is created. Once the image is created, from this image you can spin up multiple containers. So that's what I was trying to tell you. You have one image, and that's the beauty of Docker. You can spin up multiple containers here. So multiple containers as in multiple, if you look at, you might have done some hands-on, or you might have some background to understand what is a standalone Mule server. So there, what we do is you download the runtime and you create multiple different folders, right? And then each of those instances, within that you have different applications hosted. But here in this case, here you will have containerized way for each of those applications to run. So from one image, you can spin up multiple containers. So keep that in mind. And now you'll come to what is registry. So registry is, now you have created an image, you created a Docker file that is a template instruction, right? How the your runtime or how your software should be created and packaged. Now, once you have created the image, you can actually publish it to a public repository registry, or to a private registry. From where, if it is to a public registry, probably every one of you who's available here should have access to it, and you can use that image directly to spin up your own containers. So it's exposing it publicly, right? So you can expose this image publicly. Or else, if you it's just within your company, it's very private, then you just do a private registry and you expose that image, and it can be used across your enterprise. So that's about your Docker architecture. Let's go ahead. So we come to a Docker file. What is a Docker file? Now, Docker file is a template. It's which has a set of instructions. Now, if you look at this, I have just summarized key important instructions or commands that are important. Um, so if you look at that, this is a simple basic entries that we have summarized. So what is from? Okay, the first part in the from command, which tells us what image to base this upon, right? So when I show you a sample Docker file, you'll be able to correlate, how it has been written, right? So from, probably you're saying it is a JDK, you're using JDK to mention that it is based on the Java uh, SDK, right? Then we come to run. So this is what runs within the container to build at a given time. Then the volume. Specifying this in the Docker file allows you to be externally mounted by the host itself or a Docker data container. If it's not defined, then it's not possible to access these particular folders outside of your container. If you want to access those folders, then it is not possible. So that's the reason you mentioned the mount points, which has to be used, right? um, and I'm sure these mounting these points, even when you're doing your standalone without even a container, you'll always mention which is the folder from where you'll go and install it, maybe /opt/mule and all of that. So similarly here, you mentioned the volume. Then the environment variables, which you already know, it's like mule home, or any other environment variable which you want to define. You'll use the env term. Then there is expose. Sorry. So then there is expose. So if there are any ports that you would want to expose, which are required for your container to run or your application to use, so those you can define using expose. And copy, I don't think I have to explain any copy. It's simple as it sounds. You just have to, if you want to copy something, you use copy from one folder to the other, or so on and so forth. Then entry point allows you to configure a container that will run as an executable. And CMD defines the default executable of a Docker image. So basically, command and entry point are used in complementary. If you want to understand more about all these, instructions. You can, there is a very nice Docker documentation about Docker. You can go to their homepage, and there's a lot of literature. You can just go through that. We're just trying to keep it as simple so that it's much more easier for you to digest it. Yeah, so if you look at this Docker file, I'll show you the actual Docker file as well. So here, I'm just trying to explain this. So you'll see the same set of instructions mentioned here, like from, where it says, that this is using Java JDK. Then maintainer, you can put your own name. Then you have the, or maybe the enterprise name or the point of contact of your admin or some DL. You can probably give that in your maintainer. Then you have Mule installation. In this case, since we're doing it for Mule, so here you'll have all the details about the Mule. So Mule version. So we are using 4.4. Then we have, then we're defining Mule home as /opt/mule, right? Um, and then we are adding this zip file. This is the actual standalone Mule Enterprise Edition distribution. Okay, so this is the installable. So we are going to add this to the OPT folder, and then there are a set of instructions which you can see. Basically, all that we're trying to do is move this particular zip to this OPT folder and then unzip it, okay, and move it to a particular folder within Mule. Okay, we unzip it in OPT, and then we move it to Mule, and then we apply the license. This is a default license that comes with the trial. I think it is something like 30 days. 30 days, I think so. Right, Jackie, or something like that.
Yes, yes.
Uh, yeah. So then, So then you have the work directory. You're setting the work directory, and here, this is where you're defining the volume, right? So you're defining the apps, con, domain, and logs. So if you have seen the other setups, right, where we do the actual standalone, these are the basic folders, right? You have the apps, con, domain, and logs. So we're defining those, and then we're exposing the ports that we require. For us, more relevant would be the one that you see in the very first line, because we will need these, because when we are using the HTTP a port for our simple Mule application, that's when we will use this. And we might also need some of the clustering ports, so even those are exposed. And then, sorry. Yeah, so then if you look at the last step here, after exposing couple of bunch of ports, we are also doing this entry point. We're setting the entry point. So once the Docker image is created, it knows where it needs to actually start its job, right? So here, when you say dot, it is the home directory. So we might be at this point /opt/mule. Under this, you'll find the bin folder, and under that, Mule, right? So this is where we're giving the entry point, that this is where it needs to spin it up, right? All right. So I want to just quickly summarize this one. We've just broken it down into
Okay.
7 simple
Just a
steps.
minute.
Yeah.
Yeah, 1 minute. Does anybody have any question? Like, let's make this session bit interactive. If anybody have any question, they can speak up basically regarding a Docker file or about Docker container, or is everything is clear?
Yeah, I do have one question over here for Siddhima. Siddhima, so for every Docker image, does it always starts with the root like /opt, or it is specific to your only your file?
No, we can define a different one. There's no such rule, but if you look at the documentation that MuleSoft provides, if you look at Linux as a system, right? /opt is defined as a standard. So if you just Google about why OPT folder is defined in Linux, you will see, or Unix, OPT is meant for all third-party softwares. So that's the standard or best practice that is followed, and that's the reason even if you go to any of the MuleSoft documentations, you will see they will mention /opt/ and then on so on and so forth. Do it within this folder, but that's not that you cannot do it. You can define your own directories wherever you want to do it. You can do it. It would not stop you.
Yeah.
And where in
So
your image you say it's a Linux, like it's a Linux image. I don't see any command like that.
Linux is the operating system on which your Docker, you will have down, we will be first, okay, I think you'll have to just wait for this section to complete and then you'll have better understanding of what I'm talking about. Basically, we have to install the Docker. So when we install the Docker, we pick and choose which operating system we want to use. So if I go back to this, if I go back to this one, right, this Docker engine, it sits on your operating system. So when you're downloading, you'll select which operating system you want to do it for. So either it's Windows, it's Mac, and even after selecting Mac, maybe beneath whether we want to use Linux or any other, right? There are different
So
way of doing it. Yeah.
So let me just give you an example. Say for I do have a Windows laptop with me. So my
Hmm.
operating system is going to be my Windows laptop. Okay.
Yes. Yes.
And Docker engine. So when I will install the Docker engine software, I will tell the Docker engine that I want to spin up the containers with the Linux operating system. Correct?
Yeah.
Got it.
You should be
Okay.
able to
Thank
do
you.
it. You should be able to do
Okay.
it. Perfect,
Okay. Thank
perfect.
you.
You'll
Okay.
see it. You'll have more clarity when I do the hands-on and when I walk you through these 7 steps, and we actually do it, on ground. You'll have much more clarity of what I'm talking about. Sometimes it may be Latin and Greek if it's absolutely new for you.
Got it. Okay.
So let me take the other question, which is the better, Docker and Kubernetes? So you cannot compare Docker and Kubernetes,
I
basically,
wanted, yeah,
correct?
I'd want to just take that question, Jackie, if you'd not mind. I
Yeah,
think,
you can.
yeah, let's go to that topic towards the end of it. Reason is we would want to talk about beyond Docker. And let me tell you, in a one simple liner, the answer would be both are not, in case of this, it's not like you're using Docker versus Kubernetes. Kubernetes is going to be on top of Docker. Okay. So when we come to this topic here beyond Docker, I think that's when we'll want to answer that question. Right, Jackie?
Yeah. So how can we pull the image from MuleSoft registry? I don't think you have a direct access. Like it's a private. So basically, when you do the RTF installation and when you are spin up any container in RTF, right? At that time, it RTF directly pull the image from Mule registry, but you don't have a direct access basically. Okay.
Are they talking about the Docker registry here,
No, no,
Jackie?
it's they are talking about MuleSoft registry. So MuleSoft have its own Docker registry from where we can pull the image, right? So,
Yeah.
but for that, like I don't think we have a direct access to it, right? We cannot. But when you are using the runtime fabric manager or RTF on EKS, at that time when it spin up the container in Docker, it automatically pulls the images from MuleSoft registry. And you need to select the mule runtime. So depending on what runtime you are selecting, it automatically pulls. You don't, I don't think you have a direct access to it basically. Is this answer your question, Amit and Dipesh? Yes, you can go ahead, Siddhima. Yeah, Francis,
Okay.
yeah, we will definitely record the demo and publish to YouTube.
Sorry, I'm a bit under the weather today. Yeah, so so basically, we've broken down these steps into just 7 steps, very simple, just so that you can just try it on yourself, on your systems, and try to set up a mule on Docker. So what the steps that are involved is like first you would install a Docker. So if I go to this link, right? So you can see here, it gives you option to download. For me, it's giving Mac, but here if you want, you can select Windows, or if you're using a Linux system itself, then you can take that as option. Now let me, if I take this option, it would just download it for me. And I can go ahead and install it. And once you install it, you should be able to see it here. It'll just pop up for you. So there's nothing on it right now. It's bare installed one, right? So this is how you'd install a Docker. Then create a simple Mule app. You can just create simple Mule applications here, a sample demo file, a demo API, and use that for your deployment. I just created a very simple Mule application here. If you can look at it, it just has a listener. You're just setting some payload, and then a simple logger. That's it. Nothing else. No other additional stuff. A simple application. You just create a simple application. Then download a standalone Mule runtime. So if you go here, You'll get a 30 days trial version. You can give in your details and download it. That's it. So you're all set. Um, sorry. Next is, does it, Jackie, does it show a slideshow, or is it showing my entire system right now?
No, like it's showing slides. I do like it's
Yeah,
showing
let me do
slides.
like,
So yeah.
yeah, I want it in a full mode. Yeah, so that's about it. And then you create a Docker file. So I've given you I've shown you the sample of a Docker file. I've already, I have it in place. I'll just show you how it looks like. It's just like this, right? No change. So you create a Docker file. We'll share the Docker file with you if you want to do your hands-on after this session. And then you run these 5 commands, right? So what is the first command? It will build your using the Docker file. It will build an image, right? It will create an image. Once the image is created, I would want to spin up containers, right? I'm spinning up 2 containers, right? I'm spinning up this from the same image. If you see, this is the argument I'm passing here. This image is same. I'm spinning up 2 containers, container 1 and container 2. And in each of these containers, I am spinning up a mule server, right? Mule 1 and mule 2, right? So just in 5 commands, you'll all be set. There are more commands. You can do stop, you can do start, and then there will be n number of Docker commands which are available. You can just go to their manual and you'll see all of that. But we are just trying to keep it very simple so that it's easier for you to do it. Once you've done the simple part, maybe you can explore it further, right? Then once you're done with that, then what we would do is we go to the control plane, that is Anypoint Runtime Manager. We create a cluster, because once these up, right, mule servers, we will we will create a cluster of that, and then we will deploy this mule sample application onto that cluster. And what you will see is you just do a deployment to that cluster, and automatically that application will be deployed on both the instances, right? That's what you would see. um, yeah, so shall I do the DIY now, Jackie? The hands-on.
Yeah, let's first complete the PPT and then we can do the hands-on, right?
Okay, so I'll summarize this whole thing then. All right. Okay, so the benefits of Docker. So it's quicker and easier to spin. As in, you create one instance of the container from the image. You can create n number of them. It's much easier to do that. If you're doing it manually on a standalone system, it involves a lot of effort. Whereas in this case, it's pretty quick. Then it has reduced size of snapshots, and it involves less code. And there is definitely a very big takeaway, that is application isolation, right? Every application is within its own space. So what next? I think there's a very good question we got from folks asking Kubernetes, Docker versus Kubernetes, right? So it's not versus. So once you have defined your image, you have spun up containers, you have hosted your Mule servers on that, you have deployed applications, all that done, all good, great. But what happens when you have n number of those containers running, right? How are you going to orchestrate? How are you going to scale it? How are you going to deploy it? How are you going to manage those containers? It becomes very cumbersome, right? So that is when your Kubernetes comes into picture. All right. So Kubernetes is on top of your Docker, and it helps you achieve all of that. So maybe, if you want to do Kubernetes on top of the Docker that we are doing right now, maybe it can be a topic for our subsequent meetups. Jackie, you want to add anything here?
Yeah, I will add one example related to Runtime Fabric. So basically, Runtime Fabric is using both Docker and Kubernetes. So mostly Docker is used to build and deploy your application. Like you can spin up containers. So in case of microservice, or in case of like microservice, you may end up in creating n number of containers, right? And now you want to monitor those container. So basically, how you will going to monitor or manage or orchestrate those container, then Kubernetes come into the picture. The Kubernetes is basically manage, orchestrate your container. In case I will give a simple example. If your container is not performing well, or if your container is getting shut down, or it get crash, right? So who will make sure that this container again become healthy, or like, so in that case Kubernetes come into picture. The Kubernetes will try to create a new healthy instance and remove that particular instance. This is known as a fleet management. Then if you want to do some kind of auto scaling, so who will do that? The auto scaling will be done by Kubernetes. If you want to set up some ingress load balancer and all those things, so where you will going to set up those ingress load balancer, it will be on Kubernetes basically, right? So they both works together basically. Like, yeah, somebody asked question like, which is the best, Docker and Kubernetes? No, they both are separate, but they can work together basically. But they both are separate basically, so you will definitely require the Docker for deploying, for build, or to run your application. For orchestrating, for managing, for managing your application or your container, you require a Kubernetes. Is this clear? So don't get confused between a Kubernetes and Docker. So there is a no difference between Kubernetes and Docker. They are almost, there is a no versus basically. So they are different tool, but they can work together basically.
They're
And purpose is
complementary.
yeah,
Yeah, they're complementary basically. Yeah.
yeah. Thanks, Siddhi.
Yeah. Okay. So then we come to cluster. So basically, this is the cluster architecture. So basically, you'll see this. You'll have the server. You'll have the host or operating system on which your Docker engine sits. And on this Docker engine, you'll have the containers hosted. So here in our example, we are going to spin up two containers. And within each of the containers, you will see all these folders: apps, bin, lib, domain, all of that. And the runtime will be running it within this container, and we'll be deploying the applications or the Mule app to each of these. I mean, we'll just deploy it to the cluster and automatically it will be reflected across both the containers. Now, if you look at this model, you can see that you have this control plane, right? So you have Anypoint platform. Now we want to have some control on these servers, create clusters across it, deploy. So all that activity we can do from this management plane, right? So here you can create a cluster from your Anypoint platform once you see the reflection of the servers on it, and from the Mule agent, and you can. So that's how this whole thing will interplay and work together. So I think this is pretty much understood. But when we do the hands-on, you'll have a better picture as to how we are able to connect your Docker containers, and the control plane. Yeah. Can I move ahead,
Uh,
Chappy? Yeah.
Sid, I'm sorry to interrupt. I have one question.
Yeah.
So I basically come from a TIPCO background, so I'm not understanding the purpose of Anypoint platform here. Once we have the containers up and running and we have placed Kubernetes on top of our containers to manage everything, then why we need Anypoint platform?
Yeah. So Anypoint platform is your you want to take this question, Jackie, because it's more to do with the hybrid implementation. This is actually a hybrid implementation, wherein you have this hosted on Docker standalone Mule servers hosted here, and the control plane is on cloud, Anypoint runtime manager. So basically, it's a hybrid setup. But I think Jackie, you want to take this?
Gaurav, you asked this question, right, Gaurav?
Yeah,
Gaurav,
yeah.
like, it is always not necessary. You need to register your server into any point platform. I will definitely explain what is the purpose of doing that. Okay, so even like without registering your server to any point platform, you can manually set up clustering and everything. Like you have to go create a cluster.properties file within both the container and all the within both the Mule runtime. It is possible, but generally what happens? So like what we are doing, we are like creating a container or Mule runtime on the top of your Docker engine. Then we are registering to the Anypoint platform, right? Then we are creating the clustering basically, right, from the Anypoint platform. So it doesn't mean like everything will happen on from the like control plane. Just we are registering the server. We can like, from what will happen from runtime plane, all the metadata can go to the control plane, and you can see a lot of analytics, lot of monitoring, and even you can deploy your application from control plane. Like, even you can create your cluster from control plane. So basically you are getting the graphical user interface, so you can do all your operation from there. So once I, so let consider if I want to deploy the application, so I can go to any point platform, I can log in. and I can select my deployment target is a cluster. So, and this is my application, this is my jar file. So this will not going to deploy anything on your cloud hub. It will deploy everything on your on premise, but we are getting more control. You can do more control of your application. Even you can use Anypoint Runtime Manager API if you are using this particular architecture, right? It provide ARM API to perform lot of operations, basically. Like you can do the start and stop your application from your, you can do lot of automation, all those kind of thing you can do once you register your servers in your control plane. You got it, Gaurav?
Okay, okay. Got it. Thank
Basically,
you.
this is called as a hybrid
Yeah.
model. Yeah.
But
So
yeah,
we
that's
talk
not
about
necessary, right? If I
yeah,
don't want to use the controller plane and if I want to use
yeah, not
everything using
necessary. It's not necessary. It's
Kubernetes,
not
then I can
compulsory.
do that, right?
Yeah, it's not necessary, but it is recommended. But if you are going with runtime fabric manager or RT upon EKS, right? In that kind of architecture, it is necessary to register your runtime fabric in control plane. Even you are deploying, even you are setting up your runtime fabric manager on your on premise. But in case of like normal mule runtime, it is not necessary. But if you do it, like there are a lot of operation which can be simplified, like, and even like you get a lot of analytics and all those things, even you can set up a lot of alerts, out of box alerts and all those things. You can easily integrate with Splunk, and like, those kind of thing is directly available on the control plane.
Control
So
plane, yes.
if it doesn't mean like whatever you are doing on the control plane, it will be on cloud of, no, everything will be on your on premise server only. Just you are controlling your runtime manager from control plane, that's it. But your application and everything will get deployed on your on premise where your mule runtime is running. Is this clear, Gaurav?
Yes, yes. Thank you. Thanks a lot.
Yes.
Yeah, so if I can go to the next one. So we want to understand the benefits of clustering. So what clustering actually gives you, right? So clustering is a group of servers or mule runtimes which acts as a single unit. And MuleSoft Enterprise Edition supports scalable clustering to provide high availability for MuleSoft applications. In simple terms, virtual servers composed of multiple nodes, they can communicate and share information through a distributed shared memory grid, which is called as which is Hazelcast, which Mule leverages, right? Um, and if you look at it, by default, MuleSoft ensures the high availability of applications if clustering is implemented, right? So let's consider the scenario of one of the nodes in cluster crashes, right, or goes down, and your maintenance is required, right, and is under maintenance if in case. So in such cases, MuleSoft will ensure that requests are processed by other nodes in the cluster, right? So and clustering is only supported by on-premise Mule runtimes, and it is not supported in Cloud Hub. So if somebody is telling you that they can do clustering in Cloud Hub, then you should definitely question them. Right. Coming to what are the different types of clustering that we have? We have unicast, we have multicast. So let's understand that. So a unicast cluster requires that you configure the IP addresses of the nodes in the cluster. If a server has multiple interfaces using internal IP addresses, that allows the node to communicate directly with those nodes. Um, Clustering across subnets is not supported, right? And coming to multicast clusters, it comprises servers that automatically detect each other, and servers that are part of multicast clusters must be on the same network segment. And in case of multicast, you don't have to explicitly go and define the IP addresses. Okay. One advantage of multicast clusters is that this a server status doesn't need to be running to configure it as a node in cluster. Okay. And another is that you can add nodes to the cluster dynamically without restarting the cluster. So these are about it. And the one that we will be creating is going to be unicast cluster for this demo. Jackie, you want to add anything more about clustering because you're very
Yeah, I
close
will
to
add
this topic?
something about unicast and multicast clustering. People may have a doubt on unicast and multicast clustering. So when to go with unicast clustering and when to go multicast clustering. So like most of the organization doesn't support the multicast clustering, because in multicast clustering is less secure as compared to unicast, because in multicast it automatically discover the IP addresses and all those things, and like organization has to enable or discovery IP address network discovery on their environment, right? So most of the time it is disabled. So you may have to go with unicast where you have to go and explicitly define the IP addresses of your mule runtime. right? That is the only difference. But apart from that, like in case of like functioning, the cluster will function in the same way if you are using multicast or unicast clustering. There is no difference there. Only difference at the network layer. Okay.
Right. There are a few reference links which you might be interested in, where you'd want to go and download your Docker, your Mule standalone runtime, and maybe look at the commands that are available in Docker. So all of those references are listed here. We'll share it with you so you can have access to them. Yeah, I think that's about it.
There are a few
That I
questions,
can-
Praveen. Yeah, you can definitely have a run Mule runtime. You can deploy multiple Mule application on the single Docker, basically, right? You can do that. So basically, like a lot of time, their questions comes like, let's consider I'm just using my on-premise Mule runtime, right? And in that on-premise Mule runtime, we have a single runtime where we deploy all the application, but there is no isolation of the application. With Docker, you can achieve that. You can have a multiple Mule runtime, and you can have a like application deployed to that particular runtime. So basically, like for example, you can have a single Mule runtime and you can deploy a single application on top of that single mule runtime. Whenever you want to spin up second application, you can have like set up second mule runtime. On the top of that, you can deploy a second mule. So that is how you can achieve the isolation also. I don't think we get a zero downtime redeployment here. It's not that possible. But with Kubernetes, you can do that. If you are setting up the Kubernetes on the top of Docker, and if your application running on multiple replicas, right? In that case, you can achieve that. But directly with Docker, it's not possible. Yeah, you can go ahead.
So shall I go ahead with the DIY? I mean the
Yeah,
hands-on.
we will do that POC. Like we will going to showcase the demo. We run multiple runtime on a single Docker. You will see that.
Okay. So I'll go to the 7 steps. Okay. So first is install the Docker. I have already installed it. I have given the link. So if you go to this, you just download it and run it next, next, next. That's it. You're all set. You can use it for your Docker installation. Next is create a simple Mule app. I have created a simple Mule app. I don't think this is a challenge. We can share this also if you with you guys in a Git if you want to, if you want it or if you need it. And then download the standalone Mule runtime. We have downloaded that. So this is the link. You just give in all the details and you download it. It'll come as a zip, right? So step number 1, 2, and 3 are completed. Next is creating a Docker file. I'll go to the Docker file. So I have the Docker file here, right? So this is my Docker file. Okay. So I have explained this Docker file to you, the different instructions
Siddhima,
which are there.
can you increase the font bit? Because from few people. Yeah. And can
Just a
you
second.
scroll on
I'm
the
trying
left
to do.
side? Yeah, that's it. Yeah, that's good.
Yeah. So yeah. So if you look at this, they have the same set of instructions which I summarized when I did the presentation theory. So here basically you have the from, then you're defining the environments. Once you define the environment variables, then you're giving a set of instructions to unzip the standalone Mule distribution zip, add it to the Mule folder /opt/mule. Somebody asked me a question, is it mandatory to use this folder only? You can define your own folder and use it. If it is Windows, you can define it that way and you can use it, right? And you set the working directory, then you set the mount points, okay? And this will not change, right? Your apps conf, once you've set the Mule home, whatever that might be for you, in our case, it's OPT Mule. If you select something else, that's fine. This is anyways parameterized, so it'll pick up this. In this case, when it resolves, it will be /opt/mule/apps. So this apps will not change for you because that is how the product is packaged, right? It comes with apps, conf, domain, and logs folder. So this will remain same. And then you'll expose a bunch of ports which you require for your HTTP, HTTPS, and your clustering. And then you just set the command and the entry point where you want the entry point should be, and ideally this is where it should be. So that's about it. So this is your simple Docker file. Once this file is defined, we'll share it with you so you can reuse it for your own, uh, if you want to do your own hands-on, right? So we've defined the Docker file. Now what is the next step? We need to run the commands, right? So these are the list of commands that we have, right? So just want to this. I'll open a terminal at this folder.
So till like I want to explain on more concept. So basically, like if you see like let's forget about Docker for now. Like if you want to set up a Mule runtime on premise, so then, like we want to achieve the load balance, like high availability and all those things, right? So in that case, we do multiple virtual machine setup, right? And we install the Mule runtime on the both the VMs, and then then we deploy the application on both the VMs and all those things, right? Like, and we set up some Mule home on both the VMs, right? Right. So we set up the Mule runtime and all those things on the both the VM and on we set up Mule homes. We install a JDK on both the Mule runtime, all those things, right? So same thing we do in Docker also, but at a container level. So basically, you will going to install Mule runtime on the container. You will going to set up a Mule home path. You will deploy the application on container. So if you see here, we are doing the virtualization at a container level, whereas like like when we talk about the on premise where we don't use the Docker, where there we are doing the virtualization on the on the basis of operating systems, basically, right? Correct.
Yeah, that's right. Check.
So that's a difference, but we will do the same thing. Like we need to, like, the container is kind of box, so where you need to say, like, and each container is isolated, basically. So whatever available in one container, it is not shared with other container, isolated. So like
So
if
you
you are
can see
installing
this.
JDK in one container, you may have to install a JDK in other container also. Yeah.
All right. So yeah, so the next step, the next step in our 7 steps, is to run those commands. So it's to run those commands, right? Run the 5 commands. So let's do that and see how they work. So this is our Docker file. Anyways, we've explained that to you. So let's do the simple work of running these commands. Okay, I'll maximize the screen just a second. Let me just copy these commands. To maximize it. Is it visible for everyone?
Yeah, it's visible, but font a bit smaller. If you can just increase the font.
Just trying to. I had done that. I don't know. It's not working now.
Yeah, that's fine. You can clear the screen and just
Yeah.
you can just explain the
So this
command.
is your, yeah, so this is the first command. This is what is going to create your image. Okay. So let me just show you. We don't have anything right now on the Docker, right? So let me show you the dashboard. So if you see here, I go to images, I don't see anything here. Okay. It's absolutely blank, right? So now what I do is, I fire this command. What happened? Oh, it's still working. Oh, sorry.
See, Docker PS and Docker images.
Yeah, I'll do that.
So basically, it is reading the instruction from Docker file and just executing, basically.
It's creating the image, and again reiterating, you will create one image and you can spin up multiple containers with that one single image. So we'll see that.
Jackie, quick question. Is there any folder specific stuff we have to do? Like after installing the Docker, we have to go,
Folder
or it's
specific
a
in the sense.
Since like once we install the Dockers and then we can random create any folder and then execute that command, right? This
Yeah,
is the
you can.
simple stuff. Okay. We don't
Yeah.
need to do any specific configuration before that, right? Like
No,
setting
no,
up
no. Like
something.
no, no. If you want, like, if you see the initially when you install the Docker, you don't have to do anything. But in Dockerfile, if you want to use some of the volumes within your
Mhm,
container, right, you have to use that
mhm.
mount command which Siddhima explained, right?
Right.
But like initially, like when you are setting up Docker, you are just running Dockerfile, you don't have to do anything. But in Dockerfile, you need to define the instruction which are the like folder or which are the volume will be used by a Docker container, so you have to mount those volume to the container.
Okay.
I think we should continue with the flow of this installation and then come back to the questions, Jackie. Otherwise,
Yeah, yeah.
completely lose track. Yeah, so we created the image. Now, next is what we do is we spin up the containers. See, the one way that we can do the container is you can actually create it from here. You just do a run, it will automatically create a container for you. I can just do that. I just do a run. I don't give it. There here I can give name. I can say I can give the name. I can give the port, and I can simply say run, and it will create a container for me. That's how you do it from the UI, right? But if you would want to do it, control it in a way from the command line, then you can just issue this command, and it will create the container for you with the proper naming and with the right port and all of that, right? So we can do that. So I fire up this command. Now what I am doing is I have created an image. Now I want to spin up a container using that image. So I have used -d, Jackie. It's not going to display the entire stack trace on the
Okay,
console,
fine, fine.
right? That's the reason. If you don't use D, guys, you can also skip D. That is also fine. It's not a problem. It will show you the complete long steps of how that image is getting created. Sorry, how that container is getting created. My bad.
Yeah, yeah. Can you show them Docker PS and those command also?
Yeah,
Images star.
yeah. So you can see this. The container has got created. Yeah, so Docker PS. Yeah. So you can see the container is running. It lists all it lists all the processes. The instances that are running right now. So you can see this Mule server container. I wish I could maximize this. Somehow it's not working now. Yeah. So any other command you want me to fire? Docker images, we can say.
Yeah, Docker images star. Like
All the images it will show you, but there's only
yeah,
one image we have created anyway. But in Docker images, yeah, so we have one image which we have created. We've named it new Docker image, right? So you can see it listed here. You can also see it here, right? Go to images, you see it here, right?
correct.
Right. So that's a
Yeah,
coordination. Yeah. Shall I run the second command for the container?
yeah, yeah. We can create the second instance. So yeah, so that was the question has been asked from many people how we can run that. Yeah, so that is the second instance.
Okay. So this second instance is created. Now the only thing that I need to do is just give the command to create the mule server, right? And connect it with the ARM. So for doing that, first what I will do is let me go to the let me go to this runtime manager, Anypoint runtime manager. I'll say add server and copy the uh, command. Okay. Because this was created earlier, I think things might have changed. So I just a second. So from here, from your .amc, I'll just paste it here. Control V. And I don't need this SS. I'm saying mule one. The same command, I'll again paste it here. this mule2. So we have two instances. I can fire this command from here. There's also other way of doing it. If you see here, I can go to these instances. I have an option of going to CLI. Okay, I just want to tell you the other ways also of how it can be done. Now, if I see the part here, it is saying /opt/mule, right? Now I will go to cd bin, okay, and you can see this, right? In bin you have all of this. So I can fire up this command, right? This docker exec command. I can just fire up. I can just give this piece of command from here itself. It will still generate the it'll create the server mule server instance for me, but I don't want to do it from there. I want to do it from the docker command. That's the reason I'm giving it from here, right? Okay. So I'm closing this.
So like AMC setup is the utility provided by a Mule runtime for registering your server to Anypoint platform.
Right. So this is the command I fire. So it's filling it up. Done. One is created. Now, if you want to see it getting created and registered, you should see it here. So you're able to see the server here. The Mule1 server is created here, right? Let me also create the second one quickly. Okay. You can see the second one is also created. What I will do is I'll just start and stop. You can use again Docker commands to stop and start, but I want to keep it very simple for you folks, and that's the reason. So what I'll do is, see, I go to images, you click on in use, and you'll see this. You'll see the container 1, container 2, and I'll just stop this and stop this. I just want to restart it once. I'm going to start it. I'm going to start it. Okay, it's up. So just wait. Let's refresh this. You should see the servers getting started and going into the running state. So it's saying connected. Let's wait for it to come into running state. Okay, they are in running state now. Great. So let's add them to the cluster now. So I say create cluster. The console is a bit slow. You have to bear with me. Okay, it's come here. Okay, I give the cluster name. Can give something like say mule docker cluster. Are you happy with the name, Jackie? You want to name something else
Yeah,
or
that's
demo or
fine.
something like that? Okay. Anyway, and then we'll select the IPs. So this is unicast. So we are just selecting the IPs, and I just say create cluster. You can see this option here. We have selected unicast. We're not going for multicast. I say, and we've explicitly, given the IP. And by default, the port that it will take is, I think, 5601 or something like that. Yeah, we'll see. Let's create this cluster. So let's wait for it to get started.
So Siddhima, can you please explain parameters, because people are asking
Okay,
because
right.
okay, the bit content basically it will, yeah, it will take time. It will.
It'll start. It'll take time. Just a second. Let me go back to the PPT so that it's much more clear for you. I'm going to put this on slideshow. Yeah. Okay, so these are the same commands that we ran. So we'll come back to each of them. So first is we are building an image. So what are we building? We are building an image. So here this you can give any name. You can give your own name also here, right? So Docker build -t, and this name field is configurable. You can give anything. Then you say this is the tag basically. When you say -t, it's tag. Then you give the name of the image. You can say your own. You can say Surat image, or you can simply say Gaurav image. Whatever you want to give, you can give your names here. Then you have the Docker file. So you're passing the Docker file as a parameter. So -f is for file, and then you name the file that you're using. That's the Docker file, and then space dot. So when you say space dot, it's basically from which folder you're picking up. The reason I have given dot here is because I am running it from that particular folder where the Docker file is there. So it's that current folder. That's the reason I've given dot. If in case you're running it from somewhere else, you might have to give the path, right? So this is your build command. Next, we go to the creating the container. First, you have to create your image. That's a prerequisite. Once you've created your image, next you're going to spin up your containers. So how are you going to spin up the containers? This is the command. You use a Docker run command, and then you specify the port, right? Port on which you want that a container should be created or it should listen to. So this is your port that you're specifying. And then you give the name of the container, right? And then you mention the name of the image on which you want this container should create its instance. So here you will be giving this image name. So you'll need the image to create your container, right? So you give the image name. So similarly, I have created one more instance of the container. That's the command. So use your Docker run. Then you have Docker exec, right? So you want to register your
Sorry,
Mule
Sidhu.
server with the, yeah.
Sorry. So what this command is, like -i. What is that?
I think it gives you the, I think it's the information. -i is information, or I think it's index. I don't exactly recall, but
Yeah,
do
it's
you
a
recall that?
interactive mode.
Interactive mode, yes.
Okay. And -p is the port. Like any specific range we have to specify. Or it's just a random.
Basically, if you look at this port, if any request comes on, you can also change it. Like for example, if you want to say like the request is coming on 81, I want to redirect it to 82, right? You can give a different one. We have just for the demo purpose, we've just kept it very consistent. So basically, it's the port numbers that you would want to specify based on which this container would run.
Okay. We have two ports, like, and both are same. What is
I can
specific
give it
meaning of?
different. I can give
So
it
this
different.
is just the
And
in and out port, like input and
Okay.
output port. That's
yeah,
it.
it comes, yeah, the request will come on one port and the response will go on another port. If you want, you can give a different port. You can give 84, 86, or a different port you can definitely give.
But it will
I'm
work
just
for
put
the
it,
same as well, right?
it will work for the same.
Yeah, what we can do is the best way to like interpret this port is one is the host port, another is a Docker port. Okay, so that is the best way to identify these ports.
When you say host port, what does it mean? And
When the
Docker port?
request comes, yeah, when the request comes
Okay.
from the internet, it will hit the
Mhm.
host port. Host port
Okay.
will map in your request to the Docker port. Okay,
All
because you
right.
can have multiple containers, right? So
Mm-hmm.
every container will be having its own unique port. It can be same. You got the
And
point, right?
okay. So even the host will be different, like for the
Host is
different
going to be same. No, host is going to be same. Host is going to have multiple containers on it. Okay, so when you hit the request to the host, you will specify IP address in the port, right?
Right.
You can go back to this reference. I'm not sure who I'm talking to, but basically go back to this reference of container, right? When he's saying host, right? Host operating system. This is where he's talking about. On top of that, you have your Docker engine. Now there is a communication between your Docker engine and the operating system. That's where the ports would need to be defined. Does that simplify?
Yeah, that is fine. But we provided different ports so for the host as well. So how it will interact then? In the PPT as well, we have a different port for host for the image
Where?
one. And please go to the
See,
PPT
Which one? This one?
where we have the commands.
Here.
Not here. We
Yeah,
where you
okay.
explaining the commands.
Yeah, okay. Okay, let's do it in
Um,
this way.
um,
We can have multiple containers on one OS, right? You agree with that? Do
no,
you got
I
the
think
point?
he's referring to something else actually.
just a minute,
Which
Sita.
one?
just
Okay.
don't get
This,
confused. Like, let's go one
oh,
by
he's
one.
talking about this port. He's probably talking about this port. Is this one are you talking about?
Correct. The command, the
That's
run
why he's
Docker
confused.
containers only. Yeah, yeah, yeah.
No,
Yeah,
this
Only
is
so
not
that
a
port
port,
comes
right?
-p.
which one is it?
Which one?
Only
See, we
this
are spin
one
up two
is the same
container,
thing,
right?
right?
That's why two ports.
Yeah, I'm talking about only two ports that we have, the -p 8085 8085. This is just to understand what this port is all about and what is first and second. As you said, one is host port and second one is the Docker port. Is it?
Yeah,
How the request
exactly.
come? Yeah, that's right.
So, say for example, let me try to simplify this if I can. Okay, I'll try my best. So we have one container. We can spin up multiple containers and one Docker engine, right? As what has been shown on the slide right now. Right
Right.
now, each and every container is an isolated process. Okay, that means I can define same port on two containers running on the same operating system. Make sense? Say for example, I have two containers running on my OS. I can tell my containers, both the containers, to listen on the same port, 8086, 8086, because they are
Hmm.
completely two different isolated containers. Okay, but how
Right.
do I
Right.
send the request to my container? It will only come to the host, right? So then
Right.
what I'm doing is I'm telling my host, hey host, this is the port 8085, map this host port to this particular container 8086.
Right.
So that the command what she is showing you is nothing but the mapping between the ports, which ports, host and the container port.
Okay. Then in case host port should be same. We mentioned 8085 is just like an
This is just for the
8085 and
reference
80,
purpose. Yeah, this is just for
but
the
it should
reference
be same.
purpose.
You
But
can
it
It
keep
should
it
be
can be
same.
same,
different. It can
Yeah,
be
yes,
different as well.
but you
It
can
can be
have
different as
multiple ports also. Okay,
yeah,
that's
For the
not an
exactly.
host
issue.
point of view.
Yeah,
For the host point of view.
yeah.
Yes, yes.
Okay. It's not a fixed one, right?
No, up to
Okay.
you. Yeah.
Okay.
Perfect. Okay, now the cluster is up and running. If you still have questions, I don't know whom I was talking to. Your good name? Who had the
Uh, it's
question?
it's Gajanan.
Ha, Gajanan. If you still have questions, please reach out to me. We can take it
And
offline, try to help you out with it.
also, what I think, like, host always use a different port, I think, to talk with different container, right, Nikunj?
Correct,
That is
correct,
also one
correct,
thing. Just keep this
correct,
in mind, Gajana. So that's why we are defining a separate port, because host require every time a separate port to communicate with your container. It cannot communicate on the same port with a different container. It's not possible.
correct. So if that you want to do, you need to introduce that other software. What is that? Kubernetes.
True.
Kubernetes. Yeah.
Yeah, yeah.
Is this clear? Answer your question, Gajanan?
Yep, makes sense. Thank you so much, Siddhima, Jackie, and Anuj. Yeah.
If you still have questions, feel free to reach out to me. We can again discuss it. And if you're trying hands-on and you come across any issues, please let me know. Okay.
Sure, sure.
So yeah, so the cluster is created. It's running now. The next thing that we want to do is just deploy a sample application. So I'll go to the application and deploy it. Shall I do that, Jackie? Still, you want to address anything?
You can.
Yeah, perfect. Um, and here you select the cluster, right? Here you have two options. You can see Cloud Hub, you can see the Docker cluster. So I'm selecting the Docker cluster. I'm going to choose the file. It's not allowing me. It's a little slow. You'll have to wait.
So Siddhima, sorry, this is right now since it has been getting deployed. One quick question. So right now, what you will do is you will fire the request on one port, right? You cannot fire on that common port. You don't have a load balancer being set up, right?
No, I don't have a load balancer. Not right.
Yeah,
Correct,
Not right
correct.
now.
Got it.
like we,
Yeah.
we are just deploying the application. Like we will not going to test it because load balancer and everything needs to be set up, right?
Correct,
So we
correct,
don't
correct.
have
Yeah,
too
yeah,
much
yeah,
of
yeah,
time.
yeah. That is what I wanted to understand. Yeah, exactly. Yeah, yeah.
It's not giving me an option to select a file. I don't know why.
So can you check your servers are running? Like cluster is running.
Yeah, it is running.
Can you go
They're
inside that?
up and running. Yeah,
Yeah,
they're
it
up and
is running.
running.
So
Yeah.
go back. Can you give some separate good application later? Deploy application. So give some good name like Mule Docker example, Mule hyphen Docker hyphen example, example. You can select the server, Mule Docker cluster.
This is very strange. I don't know if it's become very slow. It's trying to put this.
Do one thing first, select Cloud and then select Docker. Like, select Cloud first.
It's not allowing me to choose. I use the design environment. I don't know if
Yeah,
that's the
yeah, you have
issue.
to
The
change the
sandbox.
environment. Yeah,
Wow.
Yeah.
sandbox.
Okay, let's do it again, guys. Sorry about this.
But that's fine. Don't delete the cluster. Cluster is fine.
Like but they already are using some ports and all of that
That's
stuff,
fine.
right?
You can go to just change the environment for deploying the application. Just change the cluster is fine. You see, you can see the cluster here also, I think.
No, 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 you'll not be able to see it. I'll have to create it again. Let me do that again. Let me just take the command. Okay. I'm going to run it quickly, guys. Please don't ask me questions when I do this. I just want to complete this working.
Don't give Mule 1 and Mule 2. Give some another name.
I'll say 3 and 4.
Yeah. You can just quickly execute it.
Okay. Uh, fine. All looks fine. Running. No, I don't see it. That's the mistake. Yeah, I'll have to again spin up a container, right, for this one. I cannot be doing this on the same container. I'll have to
Correct.
do it in a different
That's
one.
what I'm saying.
Okay, so let's do one thing.
Yeah, that's fine. Like application deployment is fine. Like, so everybody knows, like, once we will deploy the application, it will get deployed on both the container. And that's a simple, right? So let me check. That should
Can I
not be
just
the
clean
issue.
it up and just do it? It
It
should
will
take.
take time, Siddhima, right? No, it will take some time, right? So I think people is already right. Is this fine, right? It just we need to deploy the application. Just that's it. Like
Let me just. Yeah, I think what we can. I'll come to this step. I'll stop sharing the screen. I'll come back to the same step. You guys can continue with your quiz and all of that, and I'll come towards the end of it and probably show you the deployment. That should be fine, right, Jitendra?
yeah, it's fine.
Right, so I'll still show you the deployment. You just guys carry on with your other thing because it's going to be the same steps. The only thing that's going to change is the deployment. I'm going to come back to the same point and show you the deployment, so that should work. So I'm going to stop sharing. So Jitendra, Nitish, you can take it from here.
Thanks, Siddhima, for the great demonstration. I appreciate for your demo. Thank you so much. So, Nitish is now up to you. You can start with quizzes.
Sure, Jackie. Thank you. Uh, Great demo, Sidima. And yeah, lot of things you made clear, I guess, to everyone. Okay, so
So, guys, please provide the feedback for the session. Okay. And like Nitish, can you please run the quiz quickly because it's already
yeah, sure,
getting
sure.
late.
Yeah, sure,
Pe-
sure. So
People
hope
already
my
start
screen is
leaving.
visible. Yeah. So guys, Jackie, my screen is visible.
Yes, yes, yes.
Okay.
But I cannot see
So
that Kahoot on your screen. Yeah, now I can see.
yeah. So guys, the rules you all already know, but let's just go with that again. So we require two screens. On one screen, you'll be showing the question and the options and the time. And from the second screen, you need to choose the options with the colors. You'll be having 7 questions and 10 seconds to answer those questions each. Okay. So this is a game pin.
You have 2 more minutes to get registered on this Kahoot. Okay. Okay, I think we can start block the queues. Like people are like
Sure, Jackie. Okay, I'm locking the game now. No one else can join it. So it's locked.